Hello, today we are going to follow the tutorial Getting Started with Kirigami from the KDE community. Kirigami is a graphical user interface framework that's built on top of Qt Quick Controls 2. That's part of the QML Qt Quick from the Qt framework. So the Qt framework has two main graphical user interface wizard technologies. Widget technologies. There's Qt widgets, which is the technology that has been around since the start of the Qt framework from the middle of the 1990s. And the newer one is the QML programming language with JavaScript and the Qt Quick controls and rendering engine. Qt Quick Controls 2 extends the basic graphical user interface types which are part of QML Qt Quick. Those basic types are around geometric shapes, basic mouse manipulations, whereas Qt Quick Controls 2 provides graphical user interface type controls, which are more similar to the Qt widgets graphical user interface controls. So menus, context menus, tree views, these types of controls that you would use when you create a Qt widgets application. And then Kirigami uses all of these QML, Qt Quick Controls 2, and adds additional graphical user interface controls. How we got to this document, we started with the official KDE web page, which is kde.org. You go to the main menu, develop. In there you go again to develop, and then you search in here Kirigami, which is this part of the page, develop convergent apps with Kirigami. Responsive in the sense that, and convergent in the sense that by resizing the window, as you shrink the width of the window, the controls will move around. I know the main toolbar might move at the bottom because in mobile phones the width is very limited, and you want the main toolbar to be at the bottom of the page such that it's easier to touch with the right finger. Okay, there's Discover Kirigami and then Learn. And we're at this page. So in the KDE community, we use technologies related to QML because we want applications which work as well as possible on the Android mobile phone operating system, on Plasma Mobile, on mobile phones, and so we want the same application to work on desktop application, on desktops, on laptops, but also on Android and other mobile phone factors. And also the fact that the application that uses the QML style technologies usually respect a model view controller style split of the application. There's the graphical user interface part. What the user sees is usually coded into the QML programming language, and then the behavior, how the UI changes based on the inputs provided from the user, for instance, is usually coded in business logic. And in the KDE community, we usually write that business logic in C++, in the C++ programming language. You could also write the business logic in a JavaScript programming language, a variety of JavaScript. But in the KDE community, we prefer to not write JavaScript, to write C++. And the fact that there's this MVC-like split between backend business logic and front-end display logic makes the applications more decomposed. There's lots of small files, so the source code is split in many source code files, and many of the source code files are really small, like, I don't know, 2 screenfuls of code. And at least once the source code is written, the QML programming language files are easy to understand. Maybe not easy to modify, but easy to understand how everything is split up. Programming in MVC style with models behind the graphical user interface is not always easy to do. It's not always easy to come up with the correct backend model to which will then move the UI. And then we have bindings. Whenever the backend model changes, the UI will usually change. There's a bidirectional binding. Let's get started with the first chapter in this tutorial. So, setting up and getting started. In here, the first step would be to install the KDE framework Kirigami, which could be done by, if you have a recent enough Linux operating system that has as new as possible KDE frameworks packages, including Kirigami. You could install those, but I'm on an older operating system. I'm on Ubuntu 24.04, which has a really old version of Qt and which still uses KDE Framework 5, not 6. In this case, and in many other cases where you want to have the latest and greatest source code for the Kirigami framework straight from the Git master branch, what I recommend is to use the default KDE build tool or such a thing for following the Git master branches of various KDE Git repositories, which is kdsrc-build. I have kdsrc-build installed, and we want to build some of the KDE Git repositories, this list of KDE Git repositories, using kdsrc-build. Let's actually do that. Let me copy the entire line. kdsrc-build is an executable, this one, written in Python. The process is being started. These are the command line parameters. Looks at the list of command line parameters, sees that all of these are what's called modules. Finds out where is the Git repository which corresponds to any of these parameters. Finds out the list of Git repositories which need to be built before building Kirigami, before building K-core add-ons, K-internationalization. Creates a tree of Git repositories that need to be built, as one being a dependency of the other. Then it flattens out that tree as a list of Git repositories that need to be built in a certain order. So this is the order: extra CMake modules, ECM, kconfig, a KDE framework, kcore add-ons, a KDE framework, K-internationalization, Wayland, Plasma, Wayland protocol. So many of the KDE-src-build modules which are being built are not provided at the command line, but are computed by KDE-src-build because their dependencies of Kirigami or of a dependency of Kirigami or Breeze or any other command line parameter. In total, it needs to build 48 modules. Some of these are KDE Git repositories, other ones are not. So Wayland is not a KDE Git repository. Wayland protocols also it's not. Okay, so it failed with Sonnet. I'm going to go no stop on failure and see maybe we can build without this KDE library Sonnet. This is for spell checking. The error why Sonnet cannot build is because it cannot find the development packages, so header files, for instance, for any of the usual Linux spell checking libraries such as Hunspell, Hspell, Aspell, etc. If I install the dev package, for instance, for Hunspell, Sonnet will build correctly. Okay, so it's at module 46 out of 48. Breeze is a Qt widgets theme. QQC2 desktop style. This is a theme for not for Qt widgets, but for QML, Qt Quick controls too. So these two are in a way similar. But this is for Qt widgets. This is for the QML style technologies. I have installed the Hunspell dev deb package. I search like this, up search Hunspell and then grep for dev. And this is the package that I installed in here. And now the spell checking library has built correctly. Okay, so all of the modules except upstream have built correctly. I'm going to guess that upstream is not that important, so I'm going to just accept the fact that it did not build correctly. We can even inspect why it did not build correctly. Upstream depends on, I don't know, 20 executable tools from the Linux operating system. Now it says that there's no dev package for Pango installed. We could try to find this one. Pango is a font rendering library. Should be lib pango and then dev. The only possibility is this one. The rest are bindings for different programming languages such as Rust and C++, etc. Pascal. This guy. So the package libpango 1.0 -dev has finished installing correctly. We've built the needed modules. Let's see next. So we've installed Kirigami using KDE-src-build. And we're at this chapter, project structure. And now we'll need to create a directory and some files. Let's have the documentation take up the right half of the screen, and we'll have work be the left half of the screen. So it says that not always you need to create all of these directories and files by hand. There are other technologies. There's, ways of scaffolding a Kirigami application faster than this. But still, if we do create each individual directory and file by hand, we're going to have a deeper understanding of what's going on. So it says we need to create a directory that's named Kirigami tutorial. How do we do that? Let's start a terminal here. Ctrl-Shift-T. Go to this directory. Increase the font size. And let's make the directory. This is how the directory structure will look in a short time. So it says in there should be an SRC directory. So let's change directory to Kirigami tutorial. SRC. And we need a cmakelists.txt file. And these are explanations, and we have actual command line instructions. So instead of going make dir Kirigami tutorial, change directory, Kirigami tutorial, make directory SRC, as I did with 3 command lines, you could have done this with just one command, which says make all of these directories which are missing, starting from the current directory, Kirigami -tutorial /src. So it's going to create the Kirigami tutorial if it does not exist. If not, it's not going to create it. And then it's going to create under Kirigami tutorial the directory src if it does not exist. This is a really important command line parameter to learn for MakeDir, the -p1, which allows you to create really long directory structures. So a subdirectory in a subdirectory in a subdirectory. Okay, with touch we create empty files, and this syntax for the bash command line shell means that first this file will be created, then this file will be created. Okay, so this is the comma and curly brackets syntax. So let's go back to the parent directory such that these commands work correctly. Ctrl-Shift-V. 3. Okay, so the 3 command shows the directory structure, directories and files, the file system structure under the current directory. So it should look like this: cmakelist.txt or KDE tutorial desktop src cmakelist.txt main.cpp main.qml. Okay, let's see. It's a good idea to have consistent branding used throughout your Git project. So the Git directory should have the same name as your main executable. So in this case, Kirigami tutorial is the top level directory, and it's also the name of the executable of this that's being built from this source code, which is noted in here. KDE src Kirigami tutorial src main.cpp. So it wants a directory structure similar to what KDE src-build uses. Let's actually do that. So this is where KDE src-build is installed in the /KDE directory. So it says that I should go to the src directory there and copy the entire directory that we have just created in there. Like this. So ~KDE/src/kirigami tutorial. And then an src and main.cpp file. Okay, and now we have the contents of the actual files. Let's see how we should actually create these files. So how we should put the file's contents. What text editor does it prefer? Doesn't say anything in here. Okay, I don't know. Let's start with Kate. So we'll want to go to this directory. Let's actually use Visual Studio Code in here. Okay, so we have main.qml, this file. All of the files are empty because they have been created with a touch command line. So we can copy and paste. The better way would be for you to not copy paste, but to actually write all of these lines, mess up some capitalization, and then have the application not run, and then fix all of the bugs that you create one by one. Okay, like this, just copying, pasting entire files. I'm not sure how educational of an experience this thing is. So import Qt Quick. This is the QML Qt Quick part from the Qt framework. Layouts is still from Qt Quick QML. This is from another library, still from the Qt framework, which is called QQC2. Qt Quick Controls version 2. And this is a KDE framework named Kirigami. QML files have just one top-level element, which is called an item. The name and type of that item is main, the name of the file. And that item contains or is of type Kirigami application. In there, there's properties. The most important property for any QML. So this is the QML programming language. This is a type, which is defined in another place in here. This is a QML module, and should be just one top-level item, which we can see because there's only one top-level thing that we can collapse inside of a QML file, like this. And all of the QML types inherit from the base type, which is called item with an uppercase I. So you could say that this type is actually an item. Items have some properties. So the base type, which is item, has some properties, which means that all of the QML types have a minimum set of properties. I'm going to guess that ID is one of those. So it's the username that we provide to this instance of the object. Width and height. These, I'm not sure where they come from rectangle or from item itself. These are literal values, integer literals. I use word wrap, so if the editor's Windows width is not enough, then the text on line 4, in this case, is going to be shown on line 4, 5, and 6. This is the way I configure all of my text editors because that's the way the terminal works. The terminal never has a left, right scroll bar, only 0 scroll bars or an up-down scroll bar. The same thing I want in my text editors. I never want to scroll left and right, just up and down. That's why I have enabled word wrap, which makes text not that easy to read. In this case, translators is not line 18, but it's still part of line 17, this word. Okay, so this is how a comment can be provided with // so syntax similar to the C++ programming language and C# programming language. This is an actual source code line, so this is not a comment. This is a property title of this object. The name of the object is root. The type of the object is Kirigami.application window. This application's text comes from the previous line, from line 7. It's actually a comment. And what this thing does is makes sure that the value of the property title is the result of this right-hand side. So this right-hand side is actually a JavaScript expression, because this function, internationalization, is provided somehow, either by main.cpp or by this import. So this is a function, and this is JavaScript. Because it's a single line, probably you don't need to put curly brackets, and because it's JavaScript, maybe you don't need to put semicolon at the end of this function call. So this is a function call. We don't have syntax highlighting because we've chosen a basic text editor, which does not have, so in this case, it's Microsoft Visual Studio Code. We don't have any extension installed which provides QML programming language support, so syntax highlighting or a QML language server in order to show build warnings or syntax errors. I do have the integrated development environment from the Qt framework, which is called Qt Creator, installed on this computer. Maybe it would be a good idea to start Qt Creator and open this project in Qt Creator. This way we'll get at least QML programming language syntax highlighting, and maybe even more, like such as navigating to definitions. So let's try to do that. So Qt Creator, but then how do we open this Kirigami application? File, open file or project. We should specify either this file, cmakelist.txt, or just a directory. Let's try first with the full path to the file, Ctrl-Alt-C. Control V. What does it want to do? What is the desktop tool chain? It's Qt 5, so we want Qt 6. I'm going to deselect these, select these. So I have Qt 6.8.0 installed from the Qt Online Installer, which is an application that you can download from the Qt.io, the website of the Qt framework. Hopefully this is enough. The file is empty, no files are specified here, so we didn't make the best choice there. Close all projects and editors. File. Can we open a directory? I'm not sure how to do that. Open file or project. We can specify the name of just a directory. I have searched on the internet how to open in Qt Creator directories. And it says that we can open directories as projects using file open workspace, and then the IDE integrated development environment Qt Creator will generate its project file in the hidden directory .qtcreator/projects.json. Okay, let's try that. So file open workspace and the correct directory tilde/kd/src/kirigami-tutorial. Choose. And not this guy, but this guy. And configure project. Okay, so now we have all of the files that exist in this directory visible as part of the tree view, which with projects and file system. Where are you? Oh. In the integrated development environment Qt Creator. So we were editing the file main.qml. Package import requires a version number. No, it's the exact opposite. Must not have a version number. Okay, it complains that it cannot find the KDE framework Kirigami because this does not exist in the /usr directory. It exists in the tilde/kd/usr directory because it was built locally using kdsrc-build. And kdsrc-build in this case, it installs files in that directory tilde/kd/usr. So we're using the integrated development environment Qt Creator from the Qt framework. And now we have syntax highlighting. No other features than syntax highlighting. We're at line 18. These are additional comments where an item of type kirigami.page, which is page stack.initial page. I'm not sure what this thing is. And inside there's a label from the Qt Quick controls. You can see the aliasing in here and in here. So this is the Kirigami alias, and this is the controls alias. Okay, so there's a label which is anchor center in parent, so it should be at both vertically and horizontally inside the parent window, in the middle of the parent control, which is this one, Kirigami page. And the text inside of the label should be the result of this function call. This is the internationalization function. It's coming from the KDE community. This version has just text to translate in the language of the application that's running. So you can run the application as English language, or you can run it as Hungarian. And the correct translation will be picked for the current language that the process Kirigami-tutorial runs as. The other version of this function is one with C at the end. So this is internationalization and this is C. So that's the context for the translators. So we say that hello world is actually the title bar, the text inside of the title bar of the main window of the process. Okay, so in here we have additional explanations. Qt Quick, standard controls from Qt Quick controls. There's also layouts, maybe for, I don't know, anchors, and Kirigami. There's documentation for each of these. The Qt documentation is renowned as one of the best documentations in the industry of graphical user interface controls. Easy to read. Qt Quick controls. There's also themes such as this one, material, for Qt Quick controls. Layouts. Grid, column, row, stack layout. Page stack. Okay. And then Kirigami, which is all of these three come from the Qt framework, as you can see by the prefix in the name, Qt Quick dot. Whereas Kirigami comes from the KDE community with the prefix org.kde. The documentation is on api.kde.org for the KDE framework. For the Qt ones is at doc.qt.io. So this alias, that's customary when you import Qt Quick controls to alias it. There's applications which exist which use the Qt Quick .controls aliased as the string QQC or QQC2. Okay, in here it talks about the internationalization framework from the KDE community. There's a framework named K Internationalization KI18N, which is a library from the KDE Frameworks version 6. Oh, this one. So application window from Kirigami has a property named page stack, which is initially empty. And we're actually adding to this array with page stack pages using this property page stack dot initial page. You can have controls similar to a label in QML applications by either going the Qt Quick controls to route, which is this item controls.label, and in Qt Quick without QQC2, there's the alternative is the basic item type which exists in Qt Quick, which is called text. So Qt Quick without controls is about having creating applications similar to, I don't know, Flash player applications. So applications which are resizable, are vector-based, are about strokes and pens and geometric shapes and text. Whereas Qt Quick Controls is about controls which look similar to the other applications that exist on your computer, on your laptop. And you want to use label because it will use the correct background color, correct font, correct foreground color. So it will inherit the correct properties which makes sense for a desktop application running on your computer to use, such that it blends in correctly and looks similar to other existing desktop applications. Okay, then we're creating a .desktop file, which is about having an application launcher in the start menu, so in here, and the additional functionalities that come from it, like you can start it from other launchers, such as the KRunner, this guy. It will assign an icon to the application. The application will have a name, a description, etc. Let's see how this thing looks like. Window icons on Wayland. This is the current state of the art for naming. So desktop files should start with org.kde if they are part of the KDE community, which is the case for this application. I'm not sure why it's not Kirigami minus tutorial. Why is it just tutorial? Yeah, I'll edit this thing. Maybe I can rename it. How do we do that? Not from here. From here. F2, F2, Kirigami tutorial. So we'll keep the exact same branding everywhere, which is Kirigami minus tutorial. Okay. When will this thing refresh? Okay, it forgot the last place. Yay. What is this button? Additional highlighters for Qt Creator. Okay. We'll put this content inside of the file. Let's see if this button works, and does. So the name should be Kirigami tutorial. I don't like the fact that it doesn't have a minus, and it's a different capitalization. Okay. As I see, it's translated into various languages. So maybe it makes sense to be this user readable. The fact that the name of an application is translatable, it's something that I would never do. Why would you rename an application? If it's Zoom, it's Zoom, right? You don't rename Zoom into, German as Bildschirm etwas. Right? Makes no sense. Zoom is Zoom. Kirigami minus hello. What is happening here? Let me fix all of this. Like this. It's strange to translate branding. Why would you do that? Branding is important. Is the thing you would search on Google for, the thing you would publish on social platforms when you do a release. So your branding is vital, is extremely important. You would never translate Mozilla Firefox into different languages. Why would you do that? Okay. Next up, either copy the app's desktop file there, so it instructs me that I should copy the file in here. Maybe cmakelist.txt knows how to do this thing. Probably in this step, line 34. We'll see. If not, I'll copy the file myself to my home directory, the hidden directory.local, then share, then applications. Next up, KDE cmakelist.txt. This guy. We're using the CMake build system for most KDE projects, for the vast majority of KDE desktop applications and mobile phone applications. And this is the entry point for the CMake build system, cmakelist.txt in the top level directory. Okay. Let's see what's in here. Ctrl S. CMake minimum required. This is the mandatory first non-comment line, which should exist in the top level cmakelist.txt. So we've done what must be done. Then the project name should be the exact same as the strong branding that we're using, which is Kirigami minus tutorial. Correct. Then it says find package ECM, which will not be found because right now it only knows how to search into /usr, and this CMake package, extra CMake modules from the KDE community was installed somewhere else in ~kd/usr. These are things from this CMake module. KDE install deals, KDE CMake settings, KDE compiler settings, ECM file QML module, ECM QML module. Okay, and then it's including parts of the Qt framework. So it's including widgets. I'm not sure exactly why, because we're creating a Kirigami application. And one of the nice things about Kirigami is that you can run that application even on Android where you don't have Qt widgets. Also, I thought was one of the reasoning. So it would probably be core and Qt Quick controls too, but not widgets. Qt Quick also, yes. Okay, and then from the KDE framework, this is the list of KDE 6 frameworks that are being used. So Kirigami, we have seen internationalization before, so translating the application into different languages. K-Core add-ons. This is not directly related to Kirigami. QQC2 desktop style, so this is theming. It's for Qt Quick controls too. And Kirigami is also for Qt Quick controls too. Icon themes. I'm not sure exactly what this one is. Maybe it's for embedding some icons inside of the application as resources. Next up, it says ECM find QML module. It's including the Kirigami modules, although the KDE framework is already included. Not exactly sure how this works. Maybe this is for the this directory, org.kd.kirigami, whereas this guy is for the SO files. I'm not sure. The SO file is in here also. And then the QML modules like Qt Quick controls 2 contain both the QML files and the C++ files and are included just like this find package. No need for ECM find QML module. Okay, we have a subdirectory in the directory of the project Kirigami tutorial, this src directory with 3 files, which needs to be included as a subdirectory and must have its own CMake list.txt file. Then for the install phase, similar to make install, it says that it will copy the .desktop file, which has the wrong name, to I know, hopefully to the correct directory, which is that tilde/kd/usr/share/applications. Hopefully that's the one. But we did not configure yet the project to use tilde/kd/usr for the install target. Okay, this feature summary is an important part of CMake, where after the configure step, where it determines if the correct compiler toolchain, correct CMake modules, correct QML modules, etc. exist on the computer so the compilation can happen. It writes a summary of the modules that could be found, required modules that could be found, the optional modules that could be found, the required modules which could not be found, the optional modules which could not be found. So most CMake projects should have should use this feature summary. QML runtime dependencies are managed with ECM find QML modules. This talk of runtime dependencies is not okay. So yes, you can build this application even if you don't have the QML files from org.k.kirigami, because the QML programming language, we're not going to compile it. So we're taking advantage that we're not compiling QML files, we're just including them as resources. So we can compile even if the QML files from Kirigami are missing. What's the reason, right? You actually want to have all your dependencies installed on your computer before building. Otherwise, you're going to have just some dependencies installed on your computer. The compilation will be successful, but then when you try to run the application, either in the debugger or after you run the make install step, the application will fail. It will say could not find the QML file for, where is it? For kirigami.application window. So what's the economy in not making it mandatory that the QML files for Kirigami be present at the CMake configure step? I don't see any reason. I see only bugs created by the fact that we allow that at CMake configure step, some of the files can be missing. Not a fan of separating and acknowledging the concept of runtime dependencies. There's no runtime dependencies. Dependencies are dependencies. You should have them at compile time. Okay. And now we're going to the next file, which is this guy, add subdirectory src. A cmake.list.txt should exist in this subdirectory src. No need to specify the first mandatory line, which is cmake minimum required. We just have this on the top level cmake.list.txt in this subdirectory and other subdirectories. We don't need to specify it again. Okay, add executable Kirigami hello. So this thing should be renamed. How do we do that? Not like this. Not like this. Edit. Place. Find, replace this guy. Control F. So Kirigami hello needs to become Kirigami tutorial. Kirigami hello, Kirigami tutorial. Replace. Replace and find. Okay. So let's see what it says. It says that a executable file of type ELF will be created named Kirigami-tutorial, and ECM add QML module Kirigami tutorial. I'm not sure. It's going to create a Kirigami tutorial QML module, probably, which has this name, which again I don't like. We should use the strong branding everywhere. So probably a QML module will be created as part of this application named Kirigami tutorial also with this full path. The source code files are going to be main.cpp. QML sources for this executable are just main.qml. And as link libraries for the linker, the C++ linker, Qt modules, and KDE frameworks version 6. And then an executable will be built named Kirigami-tutorial, which is a binary ELF Linux AMD64 file, which then will be installed into tilde/kd/usr/bin. This thing. Save all. If we want to add more QML files, we need to append here. If we want to add more C++ files, can be added here. Okay, why do we need a main.cpp file? Because we're building an executable. If we only had QML files, then the entry point of the application would be a QML file, which I'm not sure exactly how that works. You would need probably to create a bash file, kirigami-tutorial.sh, which runs the entry point QML file and runs it with the QML executable or QML scene executable, depending on Qt version. So inside of that kirigami-tutorial.sh file will be the shebang, and then QML space main.qml. But we don't want to do that. We actually want to have a native executable, which is named correctly, which is Kirigami tutorial, which initializes the standard QML, Qt and KDE application, such that the application has a command line, has a -- help command line parameter, a -- version command line parameter, maybe also an about box in the help main menu, that the internationalization is set correctly, and that a QML engine is being instantiated, and we're injecting inside of the QML engine maybe some singletons, maybe additional modules, maybe additional QML files, and then we tell it, okay, now you're ready, QML engine, please start executing everything starting from the first line in a main.qml file. And it's also setting the Qt main loop. So main.cpp, this guy. Okay, so let's see what it does. It's using Qt modules, KDE Frameworks version 6 modules. It's setting up a Qt application in the standard way, which is to create a Qt application app, to not ignore the command line parameters that Kirigami minus tutorial application might receive when you start it from the command line. The desktop file is wrong, like this. The application name is wrong. Organization domain kde.org. Organization name KDE. Application name is application domain for internationalization is wrong. So should be Kirigami minus tutorial. Okay, we want to force the application to use the best supported theme and if possible also icon theme. So this is what we're trying to do in here. Breeze and org.kd.desktop from this QQC2 desktop style. Control W does work to close the current tab. File, save all. And then it's initializing a Qt Quick QML engine. This is the object. And inside of this object, it injects a K-localized context such that the internationalization files, the internationalization functions I18NC and I18N work correctly. And then, as one of the final steps, it says, hey, QML engine, please load this file. So org.kd.kirigami minus tutorial, and the item name is main, and the file is main.qml. If initialization fails, we'll return exit status -1, and then it lets the main loop of the Qt application do its thing. So this will not exit until the application is closed by the user or if the application crashes. This thing might run for days, this function call. Okay. Okay, about data is for additional command line arguments. So this is going to be a Linux executable, Kirigami minus tutorial. You can run it in a Linux terminal, and it will have some command line parameters, such as, I don't know, --help, --version, etc. And some of these command line parameters can be the output that's being shown by the application can be improved by using kabout data and adding the relevant lines in here. So this is a C++ KDE framework version 6. The first argument is the URI set in Kirigami tutorial src cmake list.txt. So this is the full path that we have used for the current for the QML module that's exported by this application in here. The second is the name of the main.qml file. Okay, let's see compiling and installing the application. We are almost at the finish line. If you want KDE src -build to handle building and installing of your project, you need to specify a custom module in your KDE src -build rc. Let's do that. Make sure all of the files are saved. File save or nothing to save. Let's see if we have put code in all of the files. Yes, 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 and yes. Okay, so let's do what it says in here. So create this thing. Let's see if $home works correctly. Ctrl-Shift-V. Okay. So at the very end of the configuration file, outside the global group, so in here, we should add this thing. Module definition for KDE src -build. The name is Kirigami-tutorial. The directory is the one that we know. No src and module. I have never seen this no src thing before. I know that --no src is the command line parameter for KDE src -build to build your module, but not do any git operations. So not do git clone, not do git fetch, not do git rebase, not do git stash, and all of the other git things that KDE src -build usually does, in order to make sure that before building a Git repository, the Git repository is actually up to date by fetching, and then the local master branch points to the remote origin master branch, such that you're not working on you're not building old source code. You're building the newest, greatest, and latest source code straight from the upstream Git repository, from origin. Whoa. Interesting. So it says that where is it? This is the cmake configure step. It was successful. Then this is the cmake build step, successful, and this is the make install, whatever, equivalent step, ninja install, and this was also successful. Let's actually look at all of the places. So we start with ~kd/src kirigami tutorial. This is where we have created the files. Then there's ~kd/build Kirigami tutorial. This is where the cmake things have happened. Inside of the bin directory should be an executable, this one Kirigami tutorial. It also put the QML module that we have created, org.kd.kirigami tutorial. Let's see how it looks like. So this is a top-level QML dir file, which says the name of the module and the fact that it contains main.qml. Main.qml, not compiled, straight QML source code, readable, unchanged. In here, it defines the types that are exported by this module. The resource files for QRC, for the Qt resource compiler executable. Okay. And the directory where the application has been installed, which is tilde/kd/usr/bin. This guy, Kirigami tutorial, and then the QML dir, where the maybe, who knows, the org.kd.kirigami-tutorial QML module has been installed. So that should be tilde/kd/usr lib this strange directory x86 64-linux-gnu, and then QML and org KDE Kirigami tutorial, and no such thing exists. Maybe because there's no cmake install rule for this thing. So it only installs the executable, not this guy. Okay, so we have used kdsrc-build. This part is not really of concern. Let's see this file, the .desktop file, if it was placed in the correct directory. So that's tilde/kd/usr/share/applications Kirigami tutorial. Not in here. Because, why? So we have the instruction here that it should copy org.kd.kirigami-tutorial.desktop. And it's in here, in the correct place. org.kd.kirigami-tutorial.desktop. And also this file is not changed. Okay. And how we start the application. Let's see. Let's see if we can run it from straight from bin by double clicking on it. This guy. Nope. So it couldn't find org.kd.kirigami, which is expected because we actually want, where is it? This a line similar to this one. So that's, we've built the application using kdsrc-build space kirigami-tutorial, and now we must run it. Yay! So what kdsrc-build -run does is, one, it sets some environment variables. which are these ones. It sets all of these environment variables. Why are they needed? In order for tilde/kd/usr. This is the only reason why this prefix.sh file exists, such that the directory tilde/kd/usr takes precedence over /usr. That's the only reason why it exists. I'm not sure why we need to export 10 environment variables instead of just one. There should be just one environment variable exported where we say, yes, we know /usr exists, but it's read-only because we're not a user root. We don't want to mess with /usr. /usr is for deb files, for the binary packages from my Linux operating system. We're using tilde/kd/usr for the software that we're building locally using kdsrc-build. We're putting that their files without being the super user. So do make sure that /kd/usr has higher priority than /usr. That's the only thing that we want to communicate using this prefix.sh file. So this is a file that can be run as is on bash. You go source space prefix.sh. And then the second thing that you do is run Kirigami -tutorial. Let's prove that that's the case. Ctrl-Shift-T. So source tilde/kd build Kirigami tutorial prefix. So source and the prefix.sh file. And then we can just run the Kirigami tutorial. Which is able to find it. The environment variable path has been edited, as you saw. At the start of the environment variable, now it's tilde/kd/usr/b. That's why which can find kirigami-tutorial because it's in this directory has been make installed. Now we can just run it. Kirigami-tutorial. This is not the way to run a command line from the terminal. You probably want to keep the bash terminal usable. So you should probably prepend this ampersand. And now the graphical user interface application is running in the background and you can continue working in your terminal in bash and do your things there. Okay, so let's see what this application does. It's titled Hello World. How do we alt tab this thing? So Hello World. Nowhere it says, does it say anything else but Hello World? It doesn't have an icon. So not expected. I'm not sure if this thing is picked up the desktop file. Maybe we need to copy the file to the directory that was mentioned above. Yes, because right now it's showing in the screenshot, we can see that it's showing the KD icon, which indeed should show because it says icon KD. Whereas in here it has the generic X11 icon, Xorg icon. So it's really strange that we have installed all of the files in tilde/kd/usr, including the desktop file, yet the currently running environment, desktop environment, which is KDE Plasma 5, does not know, so kwin, who's showing probably the icon in here and in here, doesn't know that we temporarily want to respect the .desktop files from tilde/kd/usr/share. So that's why probably we want to copy the file. So let's do that. Let's go to the start and search for .desktop. This thing. So we should copy it in here. How do we do that? We're in the source directory, tilde/kd/src/kirigami-tutorial. So we want to copy the .desktop file into this location. tilde/.local there applications. If this directory does not exist, you should create it first, like make dir -p Ctrl+Shift+V. Okay, and now you can run this command line. Let's see what files exist in here. So we have a desktop file for Kirigami tutorial. Okay. So now immediately the icon in the, without restarting the application Kirigami tutorial, kwin has detected that a new file has been added to the directory tilde/local/share/applications. It has loaded that file inside of the, probably there's a cache in there in kwin, and it has placed the correct icon in the Plasma panel. Not the correct icon in the application itself, in the application title bar yet. So let's restart the application. And now it has the correct icon both in the application title bar and in the KDE panel. Does not have the correct icon. Well, it did not have for a while the correct icon in the preview in the tooltip in KDE Plasma panel, but now it has. Okay, and when we do Alt Tab, it also shows only the correct icon everywhere. Okay. What's interesting is then what's the purpose of the application name if it's not shown anywhere. If it only shows the title, the text of the title of the main window of the application. Okay, so let's see where we are. We managed to copy source code from the documentation towards the Kirigami tutorial project. We've managed to add a module in the KDE src-build configuration file such that we can build correctly using KDE src-build and also run correctly using KDE src-build. So in here, the instructions for KDE src-build are way more complicated because they're messing up with the branding. They're not using a strong branding everywhere, which is Kirigami-tutorial for everything, for the executable name, for the application name, for the QML module, for absolutely everything. They have more things. There's one thing which is called tutorial, or at least two, for the .desktop file and for the QML module. There's Kirigami minus hello for I don't know what, the executable name. So that's why the command line is so complicated. So the command line should be, at least in my case, just kdsrc-build, the name of the module kdd-tutorial, which is also the name of the directory inside tda/kd/src, and then --run. This part is not needed. Okay. To run the new QML application in mobile mode. Let's see what that looks like. Let's start it in the desktop mode first, and then let's start it in mobile mode. What am I doing here? So it's Kirigami tutorial. Like this. They look identical. Qt Quick controls mobile 1. That's because in main.cpp it says that if this environment variable Qt Quick controls Qt Quick controls mobile. Underscore mobile or underscore style. Yeah, we need to provide the name of a style. If we do not want org.kd.desktop. What about org.kd.desktop? There's no such thing. Okay, I was just inventing, making things up. We can choose to uninstall, so to remove the files that were added into tilde/kd/usr. Instead of creating all of these files from scratch, maybe kup template or kdevelop works correctly for you. I'm not sure if that's the case. Yes, all of the graphical user interface applications should also contain a upstream metadata file. They should also contain a .svg icon, which respects the Breeze icons theme, which will be then installed into the high color icons theme. Theoretically, I know how to load this project correctly into Qt Creator so that more features will start working, such as the debugger. Okay, let's continue with the tutorial. So the tutorial has started with just creating the empty application. There exists pages in there, but just one, and just one label. Now we continue adding more and more QML items, so more and more graphical user interface controls at the application. Okay. Kirigami apps are organized in pages by using Kirigami page. Pages are the different screens of an app. You will want to have a page dedicated to specific aspects of your app's interaction. There's a stack for pages. As with stacks, you can push and pop, which means that the last pushed page is probably visible, and when you do a pop, the page that's on top disappears. You can show more than one page next to each other if you have enough width on your application. In a mobile phone, this is where the toolbar is located at the bottom, whereas in a desktop environment where you have enough width for your application, the toolbar is shown at the top. Let's see the Kirigami gallery application if we can. How do we do that? Kirigami gallery. So I have searched on Google KDE invent Kirigami gallery. KDE invent is the on-premises GitLab instance that the KDE community uses, which is at https://invent.kde.org. This is the Git repository for the Kirigami gallery graphical user interface application, which is shown in here, these screenshots. I'm going to try to build it using KDE src-build. Let's see if it works. KDE src-build Kirigami-gallery. Very few dependencies, depends on ECM. All of the KDE Git repositories depend on extra CMake modules. Then on Kirigami, which has extremely few dependencies, only depends on Qt modules, such that it can easily be used by non-KDE projects. K-item models for the MVC-like model view controller-like structure that we have for QML applications, and the executable itself, so Kirigami gallery, this Git repository. Okay, hopefully the name of the executable is Kirigami-gallery. The name of the KDE Git repository is Kirigami-gallery, which allows us to run it using KDE src-build with a simple command line. Like this. Whoa. --run. So we don't want to build, we want to run the build executable, the executable that was actually installed into tilde/kde/usr/bin. Kirigami-gallery. What's the name of Kirigami gallery then? Kirigami 2 gallery. So another moment where a strong branding such as Kirigami-gallery is not used everywhere. In here is Kirigami space gallery. In here is Kirigami-gallery. The name of the executable is actually Kirigami 2 gallery. Okay, so this is an application which is a showcase demo. It's showing the capabilities of the KDE Frameworks version 6 Kirigami. The various QML controls that are exported from this library. There's this button which has the tooltip open drawer. It's a hamburger menu. There's a main toolbar with buttons. And now we need to select the type of control that we're interested in. Let's look at the buttons first. So although everything that we see on the screen is actually painted using the QML engine, so it's only using primitives like rectangles and rounded rectangles and mouse actions, etc. By the combination of Qt Quick controls plus Kirigami on top, what it's actually presented to the user looks like and behaves similarly to Qt widgets controls. So this behaves like a combo box. This behaves like a button. Not sure what's supposed to happen in here. This behaves like a pop-up dialog, kind of. The theming is similar to the other KDE application, so it's using the a theme for Kirigami and Qt Quick controls, which resembles the default KDE theme, which is Breeze. And also the icons from the Breeze icon theme are being used, for instance, in here for buttons and toolbar buttons. This guy. This is a Breeze icon theme icon. Toggle controls. And not similar to Qt widgets applications, there's a bit of animations here and there. So this is the animation when the main toolbar appears and disappears. You can see how the hamburger menu fades to the left and how the text Kirigami gallery fades into the left and then back from the left. How the okay. The combination Kirigami plus Qt Quick Controls 2 allows you to create at least all of the graphical user interface controls and elements that you can see in this Kirigami gallery application. If the Kirigami application is very up to date, then it should present most of the controls and most of the way the controls can be configured. Another message box with custom buttons, not just OK and cancel, yes and no. Okay, let's see a progress bar. This guy. Spinner, indeterminate progress, progress from 0 to 100%. Source code. Kirigami gallery components, this guy. So Qt Quick layouts. Qt Quick controls, not named controls, but named QQC2. Kirigami alias as Kirigami. So there is a QML library that's exported by this application KDE Kirigami gallery with the name components. And we can see it in here with the info sheet action. Label. Okay, so this is about the possibilities that you have at your disposal when you're using Kirigami Gallery. Again, Kirigami Gallery is a KDE library, but has zero dependencies on other KDE libraries. As you saw, it only depends on ACM extra CMake modules, but then that's a library that's used by many other Qt projects outside of KDE. It's just maintained by the KDE community, the ECM extra CMake modules. And then Kirigami can easily be used on QML Qt projects that are not part of KDE and want to use a minimum of KDE frameworks. Very useful library to have, Kirigami, if you're using Qt Quick controls tool. Why would you not have access to well-maintained additional QML controls if you're already using Qt Quick controls tool? List view items. Oh, glitch. There is a bug in there. If I move an item, it goes to position 0, so to the top left position, but there's also a section 1 shown at the same position. So all of the items are stacked at the exact same X and Y coordinates, which is 0, 0. So this is the page stack. There's just one page and it's in a stack, it's top level, it's visible. And we're going to push a second page. The second page becomes visible and main. And if the format is mobile phone, so if the width is really small, then just the page that's on top in the stack is being shown, which is page 2. You can go to page 1 with this navigate buttons. But if the width becomes large enough, notice how in the toolbar just one button is visible, the others are hidden under the triple dot button. As I resize, more and more actions in the toolbar have space and are being displayed. At some point, the page 1 will also become visible if I increase the width of the application. At this point. Okay. So this is about the fact that Kirigami helps create applications which work correctly both on laptop, desktop computers and on devices with not enough width for graphical user interface applications such as mobile phones. Responsive. Okay. If we pop, we'll remove the page that's on top, which is page 2. If we push 2 pages and 2 more, we have pages 5 on top, 4 below that, etc. Which we can navigate with navigate back. Which maybe Kirigami Gallery is also a page. Not sure. And now we're going to rename page 4 to hello. Oh, it renamed the page on top, which is page 5. In page. What is that? So we can make a page be not hideable. How do we do if we resize the... Okay, so now we have the... We should have page 5 visible, but we've navigated to the left. So we're seeing the first page, which is hidden bottommost in the stack. And if we resize, it's showing page 1. So it's showing just the current page, but at the first moment where it can show both the current page and the second page, it will show the pinned page. So page 1 and 4, I guess. Yes, at this point. So it's pages 1 and 4. And from there on, as we increase the width, the usual behavior happens, which is this one. Okay. Global drawer mode. How do we exit here? Pop all of the pages. And somehow close the drawer. Okay, so back to the start page, the home page of the application. We have all of the pages available in a sidebar. I'm not sure how to show the sidebar. Is visible anywhere else except for the start page. More advanced widgets. Checkbox is instant apply radio buttons and radio buttons. More than one radio button in a group. Editable combo box, read-only combo box. Spinner. We did multiple columns, which is actually multiple pages. Things similar to a message box or a yellow bar, but with more colors than just yellow. Cards, which is rounded rectangles with icon, title, subtitle, buttons, etc. This is useful, for instance, for app stores. For this thing. So this is a card. Icon, title, subtitle, button. The left tool preview is being shown by default if there's enough width. And as you shrink the application, it switches to the mobile phone form factor, which is to hide the left tree view, and the buttons in the main toolbar are shown at the bottom of the application. Home, search, installed, and update, which is home, search. Where is the search? In here. Update. Okay, this is another application that is supposed to work correctly on the KDE Plasma Mobile shell for the mobile phones. But it also works correctly on desktops and laptops. Section with title but not line, section with line with title. So this is similar to, I don't know, group box. Text field would be the edit box. Text fields. What's a text field? I'm not sure why it says text fields, because it shows Kirigami actions. Or does it show? Kirigami navigation tool, navigation tab bar. This is navigation tab bar. Okay. Where? Tab bar. So there has always been a control for what's named tabs, or in various graphical user interface widget controls frameworks. There's different names for these things. Tab bar shown at the top and at the bottom. Transitions from one page to the other inside of the tab bar. Tab bars could be used in other widget libraries for implementing wizards. So you have, I know, 3 pages in a wizard. The first one, the middle one, and the final one. You drag and drop inside of the forms editor whatever you want to have on the first tab, on the second tab, or the third tab. And at the very end, you make the tab bar, so this rectangle, have height 0, so it becomes invisible. And then programmatically, when you click on a button, you're going to change from the first tab to the second tab using the next button. If you go previous, you're going to switch from the second tab to the first tab. But again, the tab bar is not being visible, and everything feels and looks like a wizard. Sliders vertical, horizontal. Progress bars, we saw them. Overlay sheet, what is that? Like a pop-up message box. And with animation, you can see the animation inside QML. So this is a modal dialog that might gray out the rest of the body of the application, or just parts of it. I'm not sure why you would use a overlay sheet instead of a actual modal dialog box. Maybe because actual modal dialog boxes don't work on mobile phones, where you only have one app displayed at a time and only one X11 window displayed at a time. Maybe that's the explanation. Dialogs. So dialogs has some bugs. Drawers. So drawers are docked panels, right, which have some transition. Radio buttons. Checkboxes and instant apply radio buttons, which seem to be named switches. Chips. What's a chip? Kind of like a checkbox, but which you can remove items from the checkbox. Okay. And we started with the buttons. Okay, so the effort is to create the needed graphical user interface applications, which the KDE community needs, and even applications which should work as well as possible both on the format of a monitor with a desktop or computer and in the format of a small width mobile phone. And as you create these applications, make sure that they work correctly and look and behave correctly. And if just plain QML and Qt Quick Controls 2 is not enough to achieve what you want in your application, then you're going to create a custom control. And then if that custom control is useful for more than your application, more than one place inside of the application, then probably it makes sense to extract that control and move it from outside from your application towards the Kirigami library. But again, Kirigami needs to stay tier 0 KDE framework version 6, such as it doesn't depend on other KDE frameworks. Okay, let's see where we go from here. So there's screenshots from the Kirigami gallery, which explain the page stack, which we just saw. Kirigami page controls page, inherits the properties. If you want to know all of the properties of Kirigami page, you will need to look at the definition of the Kirigami, so QML source code of that control. Look at the documentation, which is about that Kirigami control. But do remember that Kirigami controls do inherit from other Qt Quick 2 controls, and additional properties will be available for the Kirigami instance object because they're inherited from more basic inherited Qt Quick control items or even QML items, such as the anchoring, the width, height, etc. All of those are inherited from instance straight from the basic QML item types, such as item. Which is explained in here. Let's go in main.qml. This is exactly the source code that we had previously in this file. And we're going to increase the source code that's available inside main.qml by adding some countdowns. Kirigami page does not have a scroll bar by default, but there's another Kirigami control which is named kirigami.scrollable page, which has a scroll bar, at least up-down scroll bar. Okay, what is this? Kirigami application window. So it removed the comments to make it easier to see what's being changed. So everything stays unchanged, but the text changes. Instead of hello world, it will say day countdown. In here. And instead of using a Kirigami page for the page stack initial page, is going to use a kirigami.scrollable page. With a title. This is the moment where we should actually put the application under version control. Let's do that. So I issued the command git init here, so the current directory dot. It has created the .git directory. And now I'm using this application, which is part of the Git project, Git GUI, to add the files to the version control. And unfortunately, I'm not sure what to include and what to not include because I don't have a correct .gitignore file yet. So let's do that. So we want gitignored.qtcreator / cmake lists, this guy. and build. Really new line. And it makes sense to add these files to the version control, not autosave. The title of the message is always initial commit. Okay, now we can change the application. Maybe we're not changing it correctly, or maybe we need to see whatever we messed up. Okay, so page tag, initial page, Kirigami scrollable page, and then it puts a title instead of controls. Dot label. Control X does not work. Okay, let's remember how we built and run this application. So this thing, kdsrc-build Kirigami tutorial, and we can immediately run it eventually. Okay, so it's very similar to what we had before, but previously in here was a page with a header, but the header had no text, and we had a label inside the body of the page. Now the page's header has a text, a title, but nothing inside of the body. Different main window of the application, title, text. So using the internationalization functions is just a fancy thing. A tutorial could have started without the internationalization functions, but all of the KDE applications always translate all of the human visible strings. There's no human visible strings which are just hard-coded there. We always pass them through the internationalization function calls. Okay, so in here says that the application, the main.qml file is already too complicated. We might want to split this thing, which is the first page in the stack, to its own page named, for instance, startpage.qml. So we could put it in its own file. We could have a subdirectory QML, and then we will need to edit cmakelist.txt such that the file is picked up by the build and install. Next. Let's see what's next. Okay. We'll put things inside of the body of the only page that we have. And we can already see a model here, and a list view. So the list view is presentation, and the model is the business logic, the actual data that's going to be displayed. So let's do that. We'll keep the title, and then we'll add this thing. Kirigami.cards list view with an ID. The space was missing in here. And this is where the data that's inside of that list view will be fetched from. The model countdown model and the delegate countdown delegate. Okay. So it's a list view from Qt Quick, not from Qt Quick controls, but has a way of displaying that using Kirigami.cards. Okay. Last tutorial. What do you mean from the last tutorial? Okay. It's defining the model inside of QML. That's not the best thing you can do, but for didactic purposes, that's the way it starts. It increments, and again, QML is way easier than creating these complicated QML types and backing types in C++ source code. So let's actually do that. Okay, so we have Kirigami application window, we have a page stack. And outside the page stack, we're going to define the list model, because this requires a list model. This is the name of the list model, and this is the ID of this instance of the QML type list model. Okay, so it's an object of this type is going to be created. This is a reference to it, and inside we have just one list element with name, description, and date. So three properties which have literal string or literal integer values. Okay, we have this part done, but we're still missing this part, the countdown delegate. QML variables have to be prefixed with property unless it is inside a JS code block. I'm not sure what's saying in here. List model append, list model propget, whatever at a given index, remove, and the overwrite changes the item at location. Okay, we're getting closer to what we're missing, line 27, countdown delegate. How the data will be displayed in the list view. We have Kirigami cards list view. which is this thing, the type. Building the delegate card. Okay, and now we're defining this guy, the instance of a object of type component. Wow, huge one. So for each of the items inside the model, which is just one item, data will be fetched, an instance of this thing will be created, which is like a JavaScript object, like a JSON object. And then this data is being used in order to create just one abstract card and nothing else. Okay, and the abstract card has just one property content item. Item is the base QML type. This is actually a binding. Property implicit width will receive the value of implicit width for delegate layout, no matter how the delegate layout width and height, the delegate layouts width and height is being computed, and then the computed integer value is being set to this property. Okay, this is from the QML layouts library, which is this guy. These are the ways in which you take a QML item and you position it related to parents. You can have anchor left, anchor top, anchor right, such as the anchor bottom is not related to the parent. So this is showing a grid with how many columns and how many rows. In here says columns is either 4 or 2. And how many rows? I'm not sure. But I guess that the source code is complete at this point, so we can just run the application. I don't see anything that's not defined in here. Managing width and height in QML applications is not that trivial, because you're probably going to use bindings because you want for instance, the width of your control to respect the width that the user chooses for the window, because the user can resize the main window, or if the main window is maximized, the user can can change the resolution of the screen, for instance. And implicit width and implicit height exists such that you can compute the height, the size of children controls or the size of parent controls without entering in binding loops. For instance, if you say the height of the child item is the same as the height of the parent item, whatever. There's a complicated explanation where you might set a property of a child that then is used as a binding for the property of the parent, and then maybe the property of the child is also bound to the property of the parent, so that's an infinite loop there. Very important to learn about implicit width and implicit height, and how to exit the binding loops related to width and height. Let's actually compile the application, run the application, and see what's the application doing. Everything's saved. Okay, so very similar to what we saw in the application in the KDE App Store, in Plasma Discover, and also in the Kirigami application, which shows all of the possible Kirigami controls. This is a card with title, subtitle, button, and not an icon, but another label in here. Okay, so let's see what's actually doing. This is the main window. There's a stack of pages, only one page there, which is this thing. Inside we have a cards list view, so that would be all of this rectangle is a cards list view. There's a data model, so an array with a JSON array with just one JSON object. The object has three properties: name, description, date. Okay, and then we have the last thing, which is the countdown delegate. So that means for each of the elements in the array list model, countdown model, there should be the following QML objects hierarchy created. So a component with name countdown delegate. So components are a basic QML type that doesn't need to be, it's more basic than an item or something. Not exactly sure why didn't use item in here. Okay, there's just one control inside, which is the Kirigami abstract card, so a card, which is from here to here, this rectangle. Inside there's just one item, and it computes the width and height. Delegate layout, implicit width. What's the delegate layout? Delegate layout is the grid layout, so it pre-computes what's the size, width, and height required by grid layout, by this object delegate layout, and then that minimum required, whatever, that initial width and height are being also set initially to the component. Okay, so this is a way of making sure that whenever the application starts, the card respects the size of the window. So if you resize the window, also the size of the card will move. Okay, so we want two things. When the application starts, the card should not be wider than the width of the main window and should also be placed with correct margins, paddings, whatever, everything. So it should look correct when the application starts, and then when the user resizes, in this case, in the width of the application, the card will immediately change its width. It's pretty instant. And that's done with bindings, property bindings. Large spacing for rows. So this is a Kirigami abstract card, and this rectangle in here is the content item, which is, it has a grid layout inside, but the size of the content item is probably identical to the grid layout. It would be better if we would look at this application and actually inspect everything that's inside of here, like the live tree of controls with their parents and children. Similar to a DOM inspector in Google Chrome web browser, for instance. Okay, columns 4 or 2. What does that mean? Inside the grid layout, inside of this thing, we want 2 or 4. I'm not sure what that thing is. So this is 2 and this is 4. This is 2 and this is 3. Sure. Probably that. But again, in graphical user interface, runtime inspector would answer those questions pretty fast. So let me try to get in here the Qt inspector, runtime inspector application, which is called KDE Kirigami. I have managed to build both my application, day countdown, and KDE Kirigami using the same version of Qt, which is installed from the Qt Online installer, using the same KDE-src-build. The changes that were required are like this. I needed to add at the end of KDE-src-build rc this module, so gamma ray, the correct Git repository from GitHub. I specified the master branch, which is not needed. I specified Qt version major equals 6, which is also not needed. But then the application does not compile, fails with this CMake check on line 557 on the top level CMake list.txt file. I just commented out the line and everything worked correctly. So I could build KDE-src-build using KDE-src-build the application gamma ray. Okay, so I'm running using KDE-src-build both day countdown and gamma ray. I have connected gamma ray to the application day countdown. Inside of the title of the application, you can see injected by gamma ray. And in order to see the Qt widgets controls, you go on the widgets tab. There's nothing to see. There's only QML, and this is shown under the main tab Quick Scenes in gamma ray. So these are the items. The ones shown grayed out are not visible. It says item is invisible if you hover on top of it. Okay, now let's look at each of these and see which is which. Let's look at the source code. So we want a abstract card and a grid layout. How can we find that thing? There's a page stack, which is this thing. Then there's a layers stack, a column view layout, a column view, and we have touched the content item. So we're inside of this page stack. Scrollable page is this guy, page stack, initial page, Kirigami scrollable page. Okay, and can we see its title? Property. Yes, in here it's countdown. So this is the returned value by this function. Then says Kirigami cards list view, which should be a child with ID cards view. Where is that thing? So it's inside a control that's, we cannot see it in the source code, which is of type scroll view and has the ID scroll view. So let's look at cards view. Let's look at the source code. The source code resides inside of our executable Kirigami-tutorial, inside of the resources of the executable. In there we have the needed images for the dialogues, for the Qt dialogues, but also the only QML file that we have. There's a ton of Kirigami QML files embedded inside the resources of the application. If I interpret things correctly. Let's go back to where we were, quick scenes. So cards view is the ID, which is the name of the instance of the object. And the type is cards list view. Let's see how we can see where the cards list view is defined. I don't know how to do that. So cards list view should be a QML file with exactly this name, cards list view.qml, from the Kirigami QML module. Okay. Then we have a, I'm not sure what, inside the cards list view. So this quick item Okay, let's see how we get to the edit button directly. Where is the button? Big element, this guy. Oof. Wow. Oh, such a deep hierarchy. So scroll view, cards view, outer padding layout, header footer layout, inner padding layout, content item, delegate layout. There's a button.qml and there's this styling that's applied to the button.qml. So org.kd.quick to desktop. So this is the actual theme. Background. Can we pick the actual text? Let's see where the text is defined. Should be in here, text edit, but also in the parent probably. This guy. Okay. Where can we see the fact that there are 2 or 4 columns? This is one column. Let's inspect the other item. And this is the actual background. Delegate layout. What is the delegate layout? This guy. It's a grid layout object instance, so an object of type grid layout with name the ID delegate layout. And this guy. Has 3 elements in the grid layout. There's a heading.qml, whatever this thing is. Kirigami.heading. So it's an instance, an object of type Kirigami.heading. How do we go back? We don't. So it's heading probably in the sense that it will have a certain pre-applied style. There's a button, and then there's this thing, a column layout. Where are these? So a heading, which is this 100, a column layout, which is this label horizontal line, and then another label, and a button. So that's what the columns is. When by default there's 4 columns, although there's only 3 things to put in the columns: the heading, the column layout, and the button. So there's no 3 things to put in the columns, but 4 columns exist. So the last column is not actually used, although it exists there. So only the first 3 columns out of 4 are used by default. But then as you shrink the width, the number of columns becomes 2. And the edit button, which is the third thing, stops having its own column and will move under this column layout with the dog birthday. Okay, so I suggest that you learn Qt Quick and QML, such that you know the programming language, how bindings work, what's a property, the allowed JavaScript programming language. It's a bit different from the JavaScript programming language that you know from web browsers. And then you should inspect some existing Kirigami applications, starting with the most complicated one of them all, which is the Kirigami-gallery. Then go to the simplest one of all, which is, I know, contrast with a K from the KDE community, or calc with 2 Ks. Really simple Kirigami applications from the KDE community. Build them using KDE-src-build such that you can build the latest version from the Git. Run them using KDE-src-build. Run gamma ray, connect to it, to the running application, and inspect each and everything. You can look at the tree of control. And there are additional tools. So you can, for instance, go straight to the element in the tree view of controls that you're interested in by using this picker tool. So pick element and then click on it. There's this functionality to paint in different ways the different controls, which is quick scenes, visualize controls. You can increase the scale of the application if you don't see well enough where which control is. So it says in here abstract card. This is a button, this is a scroll view. Let's go back to 100%. So a stack view, a scroll view, an abstract card, a stack view, a button. But there's even more inside of the abstract card. I'm not sure what the other do. Okay, and you have the usual properties inspector, which also allows you to change things. So let's see this thing, the text, for instance, on the button is here. Let's make this edit too. So some of the properties you can write to, but most of the properties you can read from. Not all of the properties are editable. Picker, go here, it's a label. You can change the color. Where is that thing defined? This guy. Make it red. This. And the application repainted. So not all of the property changes you're going to make on the correct object. So they will be not applied, or they will be repainted immediately. So don't bet too much on the fact that you can change most of the properties for QML objects. And then very, very important, the functionality where it can navigate to the source code, the QML source code. Like this. So what did it do? It should navigate to lines 72. Go to creation of the what? What's this? Label. I'm not sure if the navigation is that great in here. Once more. So it wants to go to main.qml and it succeeds, and wants to go to line 78, column 29. So 78 and 29. It goes to 77 instead of 78. Yeah, it's the integration with this text rendering control is not great. There's a bug in here, so it's an off by 1 or something. It goes in here instead of going here. Okay, and that should be, you should be on your way to learning Kirigami if you do arrive as far as we did today. You're well advanced on your road to learning how to use Kirigami, how to write applications using Kirigami. There's more controls, but you should have a solid base. Again, if you know the Qt framework in general, the C++ part of it, and the QML part of it. And then you're following the Kirigami tutorial the way I do it. Thank you.